The following code is an example of using WinAPI to create an application that will be a floating window above all others and simulate a melting effect on the screen. Variable and constant definitions. Static in screen width and static in screen height, these variables will be used to store the width and height of the screen, respectively. Constant sm_, these constants represent indices for getting the width and height of the screen using the GetSystemMetrics function. Const uint ws_ex_topmost, this constant defines the window style to keep it on top of all other windows. Const uint ws_popup, this constant defines the window style as a pop-up window without a border. Const uint wm_create, wm_close, wm_paint, wm_destroy, these constants represent standard Windows messages that will be handled in the window procedure. For example, the wm_create message is sent when the window is created, wm_close when attempting to close the window, wm_paint when the window content needs to be redrawn, and wm_destroy when the window is being destroyed. Const uint copy, this constant is used when copying bitmap images using the BitBlt function and specifies the copying mode. Static read-only int ptr hwnd_desktop, hwnd_desktop is a pointer to the Windows desktop handle. This code snippet contains structured definitions and variables used in the main program to work with Windows and Windows messages. Let's break down each part in more detail. Structures. The struct layout kind, sequential, attribute is used in C# to explicitly tell the compiler how to order fields in a structure. In this case, layout kind, sequential instructs the compiler to place the structure fields in memory sequentially, in the order they are defined in the code. Definition of the point structure. Point represents the coordinates of a point on the screen and consists of two integer fields, x and y. Definition of the MSG structure. MSG represents a Windows message structure. It includes the following fields. HWND, the handle of the window to which the message is addressed. Message, the type of message. WParam and LParam, additional message parameters. Time, the time when the message was sent. Point, the cursor coordinates at the time the message was sent. WNDCLASS structure contains information about the window class that the application wants to register or create. The structure includes the following fields. Style, window style. LPFNWNDProc, pointer to the window procedure. HInstance, pointer to the application instance. HIcon, icon identifier. HCursor, cursor identifier. HBR background, brush used for window background filling. LPSZ menu name, menu resource name. LPSZ class name, window class name. Marked with the Mars-Hallis, unmanaged type.lpwstr, attribute, indicating that the LPSC menu name and LPSC class name strings will be represented in Unicode format. Declaring methods for calling functions from the Windows API libraries, user32.dll and gdi32.dll, using Platform Invocation Services, PInvoke. GetSystemMetrics retrieves various system metrics such as screen width, screen height, and others, defined by the nindex parameter. Register class W registers a window class for subsequent use in window creation. Load cursor W loads a cursor from the application or system resources. GetDC retrieves the device context for the specified window. PostQuit message places a WM_quit message in the application's message queue, which terminates the main message loop. DefWindowProc, default message handler for window procedures. CreateWindowXW creates a window with extended styles. GetMessage retrieves a message from the message queue or waits for one. SetTimer sets a timer that generates timer messages in the message queue of the specified window. Translate message translates input into messages. Dispatch message sends a message to a window procedure. Release DC releases the device context previously obtained by calling getDC. Validate rect marks a rectangular area of a window as valid for subsequent update. Kill timer removes the specified timer from the message queue of the specified window. BitBlt performs a block transfer of raster data between device contexts. Show window controls the display of a window, indicating whether it should be shown or hidden. WNDCLASS delegate, which is used to represent a window procedure. Let's examine the delegate parameters in more detail. Timer callback function, which will be periodically called according to the set timer interval. Int ptr WND equals getDC, HWND. This line retrieves the device context for the specified window using the getDC function. The device context is used for drawing graphics on the screen. Random equals new random, a new instance of the random class is created, which will be used to generate random numbers. Int x equals random, next, 0, screen with the random coordinate x is generated for the initial drawing position. Int y equals random, next, 0, 15. A random coordinate y is generated for the vertical drawing position. Int width equals random, next, 0, 200. A random width of the image is generated. The BitBlt function is used to copy a portion of the image from the WND device context to the same screen area as WND, creating a melting effect. The function parameters define the original coordinates and dimensions of the image, as well as its position on the screen. The srcopy flag specifies that the copy should be done without alteration. Release DC releases the device context previously obtained by calling getDC. Thus, the timer callback function generates random parameters to display an image on the screen and uses the BitBlt function to copy it to the screen, creating a melting effect. The WNDCLASS window procedure handles messages sent to a particular window. WM_create, this case handles the message sent when the window is created. The following actions occur here. Device contexts are obtained for the desktop and the window itself. Using the BitBlt function, an image from the desktop is copied to the window. Device contexts for the desktop and the window are released. A timer with an interval of 100 milliseconds is set, calling the timer callback function. The window is displayed on the screen using the showWindow function. WM_paint, this case handles the message sent when the window's content needs to be redrawn. WM_destroy and WM_close, these cases handle messages about closing the window. Here, the timer is stopped using the kill timer function, then the postQuit message function is called, which places the WM_quit message in the application's message queue, leading to termination of the main message loop. Default, this case handles all other messages that were not explicitly handled. Here, the def_window_proc function is called, which handles the default message. Entry point into the main application. Screen width equals GetSystemMetrics, retrieves the screen width. Screen height equals GetSystemMetrics, retrieves the screen height. Marshall.getInstance, retrieves the application instance handle, which will be used in window creation. Style equals 0, window style is set to 0. LPFN WNDCLASS sets the pointer to the WNDCLASS window procedure. HInstance sets the application instance handle. LPSZ menu name sets an empty string since the window has no menu. LPSZ class name sets the window class name. The window class is registered using the register class W function, and the class atom is returned. If the class registration is successful, class atom is not 0, a window is created using the createWindowXW function. entering the message loop. Thank you for watching. Subscribe to our channel for more exciting content. Until next time.